Hi everyone, welcome to this live session by Simplilearn. In today's session, we will be discussing the top 10 deep learning algorithms that are being widely used in the industries for solving complex problems. All the algorithms use different kinds of neural networks to perform specific tasks, so we will cover those neural networks in this video. Let's wait for a while for people to join in. We have an interesting session ahead. Towards the end of this session, I will address your queries in the Q&A session. So please feel free to put your questions in the chat section. I'll also tell you how Simplilearn can help you grow your career in deep learning. I can see a lot of them have joined in. So without any further delay, let's begin. At number 10, we have autoencoders. Autoencoders are a specific type of feed-forward neural networks where the input is the same as the output. Autoencoders were first designed in the 1980s by Geoffrey Hinton to solve unsupervised learning problems. It is a trained neural network that replicates the data from the input layer to the output layer. An autoencoder consists of three main components: the encoder, the code, and the decoder. They are structured to take an input, transform this input into a different representation. It then aims to reconstruct the original image as precisely as possible. Here, you can see there is a noisy image of a digit that is not so clearly visible. This image is fed to the autoencoder neural network. It first encodes the image and reduces the size of the input into a smaller representation. After that, it decodes the image to generate the reconstructed image. Next, at number 9, we have restricted Boltzmann machine. A restricted Boltzmann machine, or RBM, is a stochastic neural network that can learn from a probability distribution over a set of inputs. It consists of two layers. One layer is called the visible units layer, and the next layer is of the hidden units. Each visible unit is connected to all the hidden units. There is also a bias unit that is connected to all the visible units and the hidden units. There are no output nodes. RBM was also invented by Geoffrey Hinton. The algorithm is useful for dimensionality reduction, classification, regression, collaborative filtering, feature engineering, and topic modeling. Restricted Boltzmann machine constitute the building blocks of deep belief networks, or DBNs. RBM are also called energy-based models. Moving on to the next algorithm, or the neural network model. So at number 8, we have deep belief networks. Deep belief networks are generative models that consist of multiple layers of stochastic latent variables. The latent variables have binary values and are often called as hidden units. Deep belief networks are a stack of Boltzmann machines with connections between the layers, and each RBM layer communicates with both the previous and the subsequent layers. DBNs are graphical models that learn to extract a deep hierarchical representation of the training data. It produces all possible values which can be generated for the case at hand. Deep belief networks can be used for image recognition, video recognition, and motion capture data. Motion capture data involves tracking the movement of objects or people using deep belief networks. Next, at number 7, we have self-organizing map. Self-organizing maps were invented by Professor Eovo Kohonen. SOMs are a data visualization technique to reduce the dimensions of data through self-organizing artificial neural networks. The problem that data visualization attempts to solve is that humans cannot visualize high-dimensional data easily. So self-organizing maps are created to help us understand this high-dimensional data. It reduces dimensions by producing a map of usually 1 or 2 dimensions, which plot the similarities of the data by grouping similar data items together. Hence, self-organizing maps accomplish two things: they reduce dimensions and also display similarities. Below, you can see there is an input vector of different colors. This data is fed to a SOM network. self-organizing maps, then convert the data into 2D RGB values, and finally it segregates and categorizes the different colors. So you can see the green color is on the top left corner while the purple colors are to the bottom right. Moving ahead, at number 6 we have multi-layer perceptron. The multi-layer perceptron or MLP is the hello world of deep learning, a good place to start when you are learning about deep learning. Multi-layer perceptrons belong to the class of feed-forward neural network that consists of multiple layers of perceptron with activation functions. MLPs can classify datasets that are not linearly separable. A multi-layer perceptron consists of an input layer and an output layer which are fully connected. They have the same number of input and output layers but can have multiple hidden layers. Here you can see we have some images of cats and dogs. We are feeding these images to a multi-layer perceptron along with suitable activation functions to classify the images of cats and dogs. Before moving ahead, let me just recap on the neural networks and the algorithms that we have covered so far. At number 10, we saw autoencoders. At 9, we had the restricted Boltzmann machine. Then at 8, we saw deep belief networks. At 7, we looked at the self-organizing maps and how it can classify and categorize different colors. And then we had multi-layer perceptrons. Now if you have enjoyed watching this video so far, please consider subscribing to our Simplilearn channel and hit the bell icon to never miss an update. Moving ahead, at number 5 we have radial basis function network. Radial basis function networks is a special type of feed-forward neural network with radial basis functions used as activation functions. It has an input layer, a hidden layer and an output layer. The neurons in the hidden layer contain the Gaussian transfer functions whose outputs are inversely proportional to the distance from the center of the neuron. The output of the network is a linear combination of radial basis functions of the inputs and neuron parameters. And the radial basis function network performs classification by measuring the input's similarity to examples from the training set. They are majorly used for classification, regression and time series prediction. Seen on your screens is an example of the radial basis function network. So there is an input vector that is fed to the input layer. Then it has a layer of RBF neurons. The function finds the weighted sum of the inputs and the output layer has only one node per category or class of data. At number 4, we have generative adversarial network. Generative adversarial network or GAN are the generative models that create new data instances that resemble the training data. It has two parts. The generator learns to generate fake data that become negative training samples for the discriminator. The discriminator learns to distinguish between the generator's fake data and the real sample data. During the initial training, the generator produces fake data and the discriminator quickly learns to tell that it's fake. The results are sent back to the generator and discriminator to update the model. The applications of GAN have increased over a period of time. It can be used to improve astronomical images and simulate gravitational lensing of dark matter research. GANs are used as a method of upscaling low-resolution 2D textures in old video games by recreating them into 4K or higher resolutions via image training. Next, at number 3, we have recurrent neural network. Recurrent neural networks often work with sequential data that have connections to form a directed cycle. In such neural networks, the output from the previous step is fed as input to the next step. It can memorize the previous inputs due to its internal memory. Below, you can see there is an unfolded recurrent neural network. The output at time t-1 is fed as input at time t. Similarly, the output at time t is fed as input at time t+1. Recurrent neural networks have the possibility of processing input of any length. The model size does not increase with the size of the input and the computation takes into account historical information. RNNs are commonly used for image captioning, time series analysis, natural language processing, and machine translation. Here is an example of how Google's auto-completing feature works. So, there is a repository with a collection of vast volumes of most frequently occurring words. This data is fed to a recurrent neural network to train a model. Now, if you try to search for how to copy a cell in Google, it suggests you the next word should be sheets to auto-complete your search. That makes it how to copy a cell in Google Sheets. Up next, at number 2, we have long short-term memory networks. Long short-term memory networks, or LSTMs, is a special type of recurrent neural network capable of learning and memorizing long-term dependencies. Remembering information for long periods of time is their default behavior. LSTMs remember each and every information through time. It is useful in time series prediction only because of the feature to remember previous inputs as well. LSTMs have a chain-like structure, but the repeating module have a different structure. Instead of having a single neural network layer, there are 4 interacting layers communicating in a very special way. It works in a 3-step process. The first step is to forget the irrelevant parts of the previous state. The second step is to selectively update the cell state values. The final step is to output certain parts of the cell state. Some of the applications of long short-term memory networks include speech recognition, music composition, and sign language translation. Finally, at number 1, we have the convolutional neural network. Convolutional neural network, or CNN, also commonly known as ConvNets, consists of multiple different layers that are mainly used for image processing and object detection. Convolutional neural networks were first developed by Yann LeCun. The first convolutional neural network was called LeNet that was created in 1988. It was used for recognizing characters like reading zip codes and digits. Convolutional neural network consists of a convolutional layer that has several filters to perform the convolutional operation. Then it has a rectified linear unit layer, which is ReLU layer, to perform the element-wise operation. The output of this is a rectified feature map. The rectified feature map is then fed to a pooling layer. Pooling is a downsampling operation to reduce the dimensionality of the feature map. Then we convert the resultant 2D dimensional arrays from the pooled feature map into a single long continuous linear vector by flattening it. The flattened matrix from the pooling layer is fed as input to a fully connected layer to classify and identify the images. Here is an example of classifying a bird based on its features. As you can see, the network uses the convolutional layer, then performs ReLU as well as max pooling operations to extract features through multiple hidden layers. Finally, using a fully connected layer, the convolutional neural network classifies the image, which is a bird. Now let's move on to a question and answer session where we will address some of the questions that you have asked. I can see there are several questions in the chat. So there is one question that someone has asked: what are the popular deep learning frameworks that can be used for implementing these algorithms? So these algorithms or neural network models can be implemented using top libraries and frameworks such as TensorFlow, Keras, PyTorch, Theano, Chainer, etc. Each of these frameworks has its own style of processing the data and building the model. Okay, there is another question that I can see here. What is the role of encoder, code, and decoder in an autoencoder neural network? So the encoder compresses the input into a latent space representation. The encoder layer encodes the input image as a compressed representation in a reduced dimension. The code represents the compressed input which is fed to the decoder. The decoder decodes the encoded image back to the original dimension by reconstructing the image. So there's one more question I can see in the chat section here. What are the activation functions and how they are helpful? Actually, activation functions are mathematical functions that determine the output of a neural network. The function is attached to each neuron in the network and determines whether it should be activated or not, based on whether each neuron's input is relevant to the model's prediction. Some of the popular activation functions are sigmoid function, threshold function, then there's rectifier function, and there's hyperbolic tangent function. Okay, so someone has asked, what is the significance of a cost function in a neural network? So cost function is actually the measure to evaluate the performance of a model. It is also referred to as the loss or error function. It's often used to compute the error of the output layer during backpropagation. One of the examples of cost function is mean squared error. Okay, let me see if there are any more questions. Okay, so someone has asked, what does the pooling layer do in a convolutional neural network? So the pooling layer of CNN takes the rectified feature map as input. It reduces the spatial dimensions by performing a downsampling operation to reduce the dimensionality. Then it creates a pooled feature map by sliding a filter matrix over the input matrix. The pooling layer uses different filters to identify different parts of the image. For example, identifying the edges, corners, or other features of a bird. With that, I believe I have covered the important questions. If you have any more queries, do feel free to put in the chat section. Now let me show you how Simplilearn can help you get certified in deep learning and train you with some real-time projects by implementing these algorithms. So I'll search for simplilearn.com, and under what do you want to learn, I'll search for deep learning. Let me open the first two courses. So this is the deep learning course with Keras and TensorFlow certification training. It is co-developed with IBM. And if I scroll down, you can see the key features of this course. It has 34 hours of blended learning, real life industry based projects, then there's dedicated mentoring session from our industry expert faculties, there's flexibility to choose classes, then there's 24/7 support as well. And on the right, you can see the skills covered. So we'll learn Keras and TensorFlow framework, PyTorch and its elements, learn about image classification, artificial neural networks, autoencoders, other deep learning networks, convolutional neural networks, recurrent neural networks, and many more. If I scroll further, here you can see the entire course content. So there's introduction to TensorFlow. You'll learn about convolutional neural networks. Then there's deep learning with Keras and TensorFlow live classes. There are some practice projects. You'll also get a free course about math refresher and about deep learning fundamentals as well. Now these are the two projects. If I go to my next course, so this is the postgraduate program in AI and machine learning. This is in collaboration with Purdue University and in collaboration with IBM as well. If I scroll down, here are the key features. Now this is how the Purdue certificate would look like once you complete this course, and you'll also get an IBM certification. Now Simplilearn also gives you job assist in this program, so you will get IIMJobs Pro membership for 6 months. There's resume assistance and career monitoring. There's interview preparation and career fairs. Now here are the program details. So we'll learn Python for data science. There's data science with Python, machine learning, deep learning with TensorFlow and Keras. Then there's advanced deep learning and computer vision. There's natural language processing and speech recognition. If I expand it, you also have the option to choose a few electives where you can learn about IBM Watson for chatbots, machine learning with R. So these are some of the skills that will be covered. You'll learn about statistics, Python, supervised learning, computer vision, NLP, GANs, speech recognition, ensemble learning, recommender systems. And here are the tools that will be covered as part of this course. And if I scroll down, you can see the industry-based projects. With that, we have come to the end of this live session. I hope it was interesting and informative. If you liked it, please let us know in the comments section. Don't forget to subscribe to our channel and stay tuned for more from Simplilearn.